Okay, so we'll have a quick look at Venn diagrams and have some revision on those as well. We've got a situation where there's 25 people in the class, and let's say that 13 do maths and 14 do physics. And your first thought is, hang on a second, if I do 13 plus 14, it gives me 27, and how's that going to work? But remember that the reason that we get that overlap is that we could have some that do both, and in fact the number that we're over 25, the number that we're over the expected amount, is the number that's in the overlap, because if we count all the people in the physics circle and all the people in the math circle, we've counted the overlap twice, the ones in the intersection twice, and that gives us two too many, so there must be two in the intersection. So I can then adjust the numbers in each of the circles. So people just doing maths would be 11, because I know there's 13 in total, and people just doing physics is 12, because there's 14 in total. Two do both. 12, 14, 25. So actually there's no students in this case that don't do maths and physics. Everyone in the group does maths and physics. So that's a quick reminder about Venn diagrams. But we're talking about probability. So let's say the probability that we choose a student from the group that does physics and maths. Well, there's 25 in the group, 2 of whom do physics and maths, so it must be 2 and 25, simple enough. Then what we're talking about at the moment is the probability that someone does physics, given that they do maths. Now again, the same as with the two-way table, we're restricting the number of things that we've got. We're restricting the group. Given that they do maths, all we're interested in now is the mathematicians. Now the mathematicians are all in this circle here, and there's only 13 of them. So given that restricts our group to 13, all the people just doing physics can now leave. All the people doing neither can leave. We're only interested in the mathematicians, given that they do maths. If I see how many people do physics, given that they do maths, it must be 2 in 13. And again, I can just read it off the Venn diagram. So 2 in 13. But again, how does that tie in with what we talked about before? This formula of physics and maths divided by the probability that they do maths. But again, if I fill in those probabilities, the probability they do physics and maths, if I'm choosing from the group, is 2 in 25. That's what we did up here. If I ask what the probability of choosing someone that does maths from the group is, well, there's 13 mathematicians out of the 25. If I do this fraction divided by this fraction, I flip this one over, I multiply them, I cancel out by diagonals, and I'm left with 2 over 13. So I get the same answer. Now again, I'm not saying you have to use this formula in this situation. Given that they do maths restricts the group, I can see there's 13 people that do maths, 2 of whom also do physics, so it's a 2 in 13 chance. Like the two-way table, I don't need to use this formula particularly in this case, but you can see the formula works, and that's going to help us again when we do tree diagrams.